Hello guys, you on probability revision course, this foundation, and that's for GCSE, iGCSE programs. If you're new here, if you want to know basics, that's right video for you. If you're advanced student and you're already aware of classical definition probability, so how to calculate probability of the single event, so you're welcome to advanced course. It's called crash course, all types of questions where I actually consider different instruments in order to investigate and explore combined events, compound events. This is about advanced level. So welcome to and follow the link in the description below so you can go to advanced course. However, here this is foundation and we consider some basics example so that you get an understanding about probability. All right, so that's introduction. So you need to be aware of that. You might have different statements, and they might indicate likelihood or a chance of some particular event happening. Let's say, when we're trying to predict results of challenging of two teams, let's say basketball teams, Tigers versus say Wildcats probably. Okay, so the Wildcats will probably beat Tigers or vice versa. Tigers might beat Wildcats, but I'm not sure about that. So those statements indicate the likelihood or chance of a particular event happening. In this case, event is basically winning of some of a certain team, Tigers or Wildcats. Okay, so that's about probability, all right? Or sometimes you might have a statement, I'll probably, make video on YouTube, all right? That's also a probable statement where you might do this or might not do, depending on some circumstances, all right? If we're talking about, winning in the lottery, that's the same. That's about probability. So your statement may sound like really certain. That means probability or chance is very close to 100%. Let's say 99%. In this case, it's really extremely high probability of what you were expected to do or what you expect to happen. If you heard the prognosis or forecast, weather forecast about the rain, so that's soon gonna be rainy, so that means it extremely likely that it's going to be raining within 2 hours. Okay, so this sounds also more affirmative. That means it's really likely event to occur. However, in math we need some numbers, and that means we using probability as the fraction of, let's say, classical definition, a fraction of number successful events, success over total number of events. That's how we can estimate probability. Let's say we toss in the coin, there might be head, there might be tails, and let's say in 100 toss there will be about 53 cases or occasions that head appears. So when we toss the coin, there might be head, there might be tail, and out of 100 times of tossing, there might be 53 times the head occur. In this case, you can say that in resport that means 47 times tail occurs, right? So what it means they're almost equally likely. So that's why you estimate percentage probability as for having heads as 50% around, but actual results will give you 53. So it looks like maybe it's not enough time you made tossing in this case. So that's why your statistics is not really representative. Those words you might hear at your classes, at your probability and statistics classes. So your statistics need to be really representative. Probably if you repeat this experiment maybe 1,000 times or 1 million times, maybe you have more closer results to 50%, all right? Anyway, that's about estimation. And let's go to the problems. Let's consider several problems because that's revision. Here we go. We have the problem 1. So grab a pen, grab a paper, and right now we're gonna go through problem 1 together. You may pause the video, try to do by your own, and then compare it with my explanation. So we have the following probabilities. Event A and probability as 2/3, event B 60%, and event C probability is 0.23. So which event A most likely, B least likely, and C you need to, for the following probabilities that you're given below, assign suitable phrases. Okay, and you need to be aware what sort of phrases you might use. Okay, so that might be definitely not occur, certain to occur, or highly likely, or less likely, or very unlikely, so or probably impossible, or extremely unlikely. So you need to use the proper phrases. I hope you understand how to work it out, and let's start doing it together. So for the first case, when you have 2/3, you have percentage and you have decimal, it's highly recommended to convert into one format. So I prefer decimals, so that's why this we basically leave as 0.23. However, 60% we convert into decimal, we basically divide by 100 and we get 0.6. This is probability of event B. And what about 2/3? You can use calculator. However, I know that if it times by by 3.3333, so 3 occurring, we'll get 0.66 occurring. Okay, so you may check using calculator. You take 2/3 and we get this exactly. So we have PA, which is 0.66, PB is 0.6, and PC we still have 0.23. So the question is the most likely event. In this case, the event is most likely when it has more probability in comparison with other. So definitely this event is the most likely because it has the high probability. Least likely, the probability should be the lowest one. So for the least likely, we have event C with probability 0.23. On top of that, if you set up the line, we have one end to be 0 probability, that's probability line, and other tip is going to be 1, and we measure as a fraction, so probability measure probability just as decimals from 0 to 1. We understand that 0.23 is going to be very, very close to 0. So 0.23. So what can you say about that? Definitely this event is very unlikely if you pick up an appropriate phrase. So that's why it definitely least likely in comparison with other and just absolutely. All right, let's go to the next one. For the following probabilities, you need to assign suitable phrases. 0%, 0.54, 0.22, and so on. For this reason, I set up the probability line, or basically number line, where you can basically pick up appropriate words for given decimal numbers. All right, let's go to the next slide. We can have it here. That what I'm saying, that's probability line that goes from 0 to 1. And we have appropriate phrases depending where we are on that line. So what we can do, we can divide first of all by half. So the middle point and probability around that point, somewhere here, they will be equally likely. Okay, so because probability is around 0.5, maybe plus minus 0.005, so within this range, that's okay. So next one, here this range is unlikely, so set up another color, maybe that one. It's unlikely and the same as likely. So it's, I think it's between 0.3 to 0.5, let's say 0.7, maybe 0.68. So very likely if events between 0.7 to, let's say, 0.8 probably, and extremely likely is the rest part, maybe 0.8, 0.85 might be. So extremely likely within 0.85 up to 1. Okay, the same way you can estimate right there. So extremely very unlikely, and extremely unlikely with 0 to be impossible. So extremely unlikely is right there, very unlikely is right there. Okay, according to this, or using this probability line, we can pick out the suitable phrases for 0. So what can you say about 0? 0 is definitely impossible. So here I'm going to use arrows. So let's take that one. So 0, it's definitely impossible. What about 0.54? It's definitely around 1/2 or around 0.5, plus minus 0.05. In this case, we can consider that events with this probability 0.54 is going to be equally likely. Okay, so that's 50% of happening and not happening, for example. What about 0.202? That's definitely very unlikely, because that's about this range. So probably it's on the boundary between extremely unlikely and very unlikely. So I would like to set up right there. Okay, 1/3, but as percentage. So make sure you don't miss out percentage. So that means if we convert into decimal, we're gonna have what? 1/300 in this case, because we need to divide by 100% as well. So we've got 1/300, and we've got very small number, 0, 0, 0, and 3 recurring. Okay, so that means it's really extremely unlikely. So that's why we're gonna use that color and say that this is actually extremely unlikely. What about 78%? That's really very likely, and it's definitely 1. Okay, well, I'm using this red color, so I'm gonna use, let's say, that color. Let's use, so extremely, no, very likely. It's actually close to 0.85, but still not extremely likely. Extremely likely, it's more than 0.85, or even close to 0.9 and more. Okay, so here is the fraction. Let's say someone estimate probability is 1000 to 4001. So that's roughly, even not without using calculator, you can cancel by 1000 and you'll get 1/4. 1/4 as decimal is 0.25. What can you say about 0.25? So 0.25 is definitely very unlikely, so I can set up in the same category as I set up 1/3%. So that's extremely unlikely. Sorry, not that, but 0.202. So very unlikely. So I do the same for that one. Okay. What about 1? That's definitely certain event. So I'm going to use that color for certain event, and it's right there. Okay, so hope you keep track on it. If not, just have a look at the picture. We have errors everywhere, and they go towards the appropriate phrases from probability figures. All right, so hope you understand how to estimate and basically analyze probability and convert into appropriate phrases, and we move next. Here is the problem 2, and we have a circular spinner colored red, green, and blue on 3 equal sectors. All right, so we need to estimate the probability of getting a red sector if the spinner was twirled 135 times and finished on red 49 times. Okay, so what about 3 equal sectors within the circle? I just want to use that one. Let's say this is the circle and circle is spinner, and we have several parts within it. Okay, I'm just quick to switch that. Okay, so now we have this one. So what can you say about the angle if we have 3 equal sectors? What stays for each angle of the sector? Yeah, right, so we've got 360 in total, and for each sector, because equal sector means we equally divide 360 by 3, that means for each sector there is 120 degrees. If we set up the angles, we basically need to split up on 3 equal parts, or basically measure the angle 120. So that's basically sectors with different colors. We can set up red. Let's say this is red, then there's going to be a green one, and the last one is blue. We just set up letters instead of shading. Okay, so that's ideally. And if you want to estimate ideal probability, so probability of getting green sector according to the angle 120 degrees, and basically because there are 3 equal sectors, it's going to be 1 over 3. Or if you want, you can calculate as 120 degrees on the degrees basis over 360. You will come to 1 over 3 anyway. So probability for the blue one, the same, and probability for the red one is also the same, 1 over 3. So that if you add up all the probabilities, you'll get 3 over 3. So if you add them up, that would mean that during spinning, definitely one of the color will occur. So that means probability of green, or let's say blue or red to occur is going to be 3 over 3 or just 1. Basically, you need to add up all those probabilities. Okay, however, we have a different problem here. This is just, I show you to make sure you understand about ideal probability. But here we have an experiment, and we're trying to estimate probability that really occurred during the experiment. We've got 135 times, and it finished on red 49 times. We need to estimate probability of getting red. So question A, probability of getting red color as actual probability that is based on experiment is going to be simply, by definition, number of favorable times that red occurred, that's favorable, over the total number of times it was spun. Okay, so that's total number of times. In our case, we've got 135 times, sorry, my bad, it twirled 135 in total, and it finished on red 49 times. So that's why favorable events is going to be 49 times. All right, so let's calculate probability and let's see how much is that. So 49 over 135. And we'll get probability of being read as 0.36 to 2 decimal places, okay? 2 decimal places. If you compare it with ideal probability of getting read, so probability ideal or theoretical probability is going to be 0.33, so 3 recurrent. It's very close actually. Probably if you repeat this process, maybe not 100, but really much more, like 10,000 times, you'll definitely have a 33 or somewhere around percentage probability of getting a right one. But we have also question B, let's figure out, using the result for A, so based on the actual probability, calculate the probability of getting either blue or green sector. So what it means, we understand that either red or other color occur, let's say green or blue. And we want to estimate probability of having green or blue. So what we can do in this case, we know that in total, even actual probability, so in total, if we add all those probability, we need to get 1. That's definitely the case. So how we can calculate probability, green or blue? Basically assume that this one big sector, and we have red. So 2 events, getting red or getting green or blue, they are complementary events. Complementary. So what it means? It means that if event R occurred, so that means the other events, green or blue, that form the full set of all possible outcomes. So that means you can say green or blue together is the same as not red. So we have red, either red or not red, which is green or blue. Now, there are no other possibilities or no other events that might occur except for green or blue. So that's why basically green and blue are complementary to the red. So how to calculate probability? We know that if we add probability of red with not red, we should get 1. Because either of those events occur. So that means we have a certain chance of getting red or getting green and blue. So what it means that in order to express probability of not R, that means green or blue, we simply need to subtract from 1 probability of getting red. So that's why probability of getting green or blue is simply 1 minus probability of getting red. And numbers, let's go to numbers. We need to use the result for A, and we've got the result 0.36. So that means probability in B part of getting green or blue is going to be 1 minus 0.36, which means green or blue is going to be 0.64 to 2 decimal place. And that's going to be the answer for B part. Okay, so we've done the first A. The answer is right there, 0.36 to 2 decimal places and 0.64. If you're asked clearly to convert it into percentage, so you need to times by 100, but be careful about decimal place. If you need to have 2 decimal place as the percentage, you need to have 4 decimal place and in decimal format, all right? So make sure you understand that. And let's go to the last problem here. So what we have 2 coins that were tossed 8 So 489 times. And the number of heads observed at each trial was recorded. Okay, so 2 coins, there might be head, there might be tail for each coin, but because 2 coins were tossed 489 times, that means there might be no heads, means 2 tails, there might be 1 head on at least 1 coin, and there might be 2 heads, okay? So we've got the results as shown in the table. However, the table is not completely filled up. So estimate the chance of the following events occurring. So 0 heads, 1 head, and 2 heads. So first of all, I think we need to finalize the table because we use the frequency, right? So we're going to use the frequency, and relative frequency basically will be an estimation of probability. Here is the column for relative frequency, which means that it's going to be the column that defines probability. So that's the same as probability. And this is how we can estimate probability using relative frequency. All right, so first of all, let's set up frequency. For 2 heads, we have unknown here, but we know that total number of times, frequency means number of times the coin were tossed, is going to be 849. So what we can do, we set up the total 889. And in order to find the total, not total, but number of times where 2 heads occurred during statistical experiment, we just simply need to subtract. So for 2 heads, frequency for 2 heads is simply 489 minus the total of 121 and 230. All right, so let's do this using calculator. Or if you like, you can do mentally. 489 minus the sum of 121 and 230. And we've got 138. This figure will stay for number of 2 heads times number of, so basically how many times 2 heads appear. It's going to be 138 because that result is 138 times. All right, so let's go back to the questions. So what we need to do, we need to estimate the chance of the following event occurring. 0 heads, and we go to relative frequency. All right, so we go to relative frequency right now, and relative frequency by definition is what? Relative. It means your current frequency of a given event over total frequency. In our case, we have the total frequency 489, and for a given event we have 121. What we're going to do, we just simply write that it's 121 over 489. That was stays for 0 heads. Okay, when we have 0 heads, relative frequency is going to be, let's divide 121 over 489. This is going to be 0. I will use 4 decimal place in this case, so probability up to 4 dp, and it's going to be 0.2474. 2474. That's the probability of getting 0 heads. So in terms of the words, you can say that I may say that it's very unlikely. It's between very unlikely and unlikely. So 0 heads, really less likely that this event will occur. Definitely there will be at least 1 head. Okay, let's go to 1 head and calculate in the same manner 230 over the total frequency. And we get, for this number, we get relative frequency 0.4703. Okay, so this event having one head, it's basically, we can say it's around equally likely, like 50%, but still, because it's still like less than 0.5, so we can say, anyway, we can say that's equally likely anyway. And what about two heads? 138. 138 we divide by 489. And we've got again less likely figure, or very unlikely, and I've got 2822. So we estimate probability of getting 0 heads is 0.2474. 1 head is 0.4703, and 2 heads 0.2822. So both those events are very unlikely. So this one is going to be like unlikely, somewhere on the boundary, unlikely. And this event has about 50% probability, so sort of equally likely. Okay, so that was revision, and we considered all 3 problems. That was the basics, how we can estimate probability, how you can basically use using the historical probability, historical data, how you can again estimate probability from this point of view. Also, make sure you understand how to calculate theoretical probability. We also touched this question here. The basis was the angle of the sector. So 3 equal sectors, and we used the angle as the basis to calculate the probability. That's again estimation of theoretical probability. However, there was the difference between actual during experiment, the actual probability with theoretical one. However, the difference is just a slight difference, not so really significant. So that's why we can say that experiment, the data in the experiment really reliable, and experiment tells or proves that the actual probability is very close to theoretical ones. Okay, that will be done. That was basics. Hope you understand that, and I hope you like that. Don't forget to subscribe, and don't forget to smash the bell button. In this case, you will be notified by latest updates. And if you're sure that it's pretty easy for you guys, try to go through the following revision. For the next part, we'll actually be using expectations and doing more complicated problems and questions. And make sure you also watch the crash course for probability, when actually I recap and provide all theoretical basis, and also provide really lots of examples and exam styles questions and problems, so that you can also practice by your own. That was Daniel Dallas, and peace out.